dokies, artichokes, let's get started. So, today we are going to be doing a lesson on dilation. Now, you should have seen this in the Minecraft world already, so you should be pretty familiar with the idea of what dilation is. If you're not, though, dilation is the act of taking a shape like this quadrilateral and making it bigger or smaller based on what you multiply the coordinates by. We call multiplying the coordinates a scale factor, which was explained in the Minecraft if you did that. If you did not do the Minecraft, I'd recommend going back and playing the dilation section. It is quite enjoyable and will explain to you further what a scale factor is. So today, we're going to be doing a couple little experiments. So first, we are going to multiply by a scale factor of 2. Then we're going to multiply by a scale factor of -1. And then lastly, we're going to multiply by a scale factor of 1/4. Before we multiply these coordinates by a scale factor of 2, I want you to take a guess in the Nearpod. What do you think is going to happen to this quadrilateral? Okay, let's see if your guess was correct. I'm going to do this one in orange, because these shapes will overlap quite a bit. So starting with this first coordinate, the coordinate is 2, 5. So I need to multiply each piece here by 2. So let's put those over here. So 2, 5. If I multiply everything by 2, I have 4, 10. Okay, so if I go over here, go to 4, up to 10, I'm going to put a dot. That is where this corner is now going to be in my shape. I'm trying not to give away what's going to happen to it. So let's do 5, 5 now. So 5, 5 is going to be 10, 10 if I multiply both of those pieces by 2. So if we go over to 10 on the X, sorry, my camera's focusing a lot, and then up to 10. Okay, so that is this side right here. We can connect the dots. Okay, 2 more points. 3, 1. 3 times 2 is 6, and 2 times 1 is 2. So that leaves me with 6, 2. Okay, so I'm going to get out my ruler and connect these dots here. Is what you think happening? Let's find out. One more to go. Come on, camera, you can do it. Focus. We're going to do 2, 1. So 2 times 2 is 4. 1 times 2 is 2. So 4, 2 is right here. Connect the final dots. Okay, if you said something to the effect of, it's going to get 2 times bigger, you would be correct. However, it's also kind of moved up a little bit because I've increased the numbers. That means that my shape has moved just a tiny bit on my graph. But basically, I have increased by 2. So doubled the size of my shape. So let's rewrite our coordinates. So we have 4, 10, 10, 10, 6, 2, and we'll have to write it inside the shape, 4, 2. Okay, that is multiplying by 2. So again, if you said it doubled in size, you would be correct. We're going to do this next one in brown. If you're wondering why I'm not using bright colors, because I've basically run out of all of them because I like to use them so much. Our next one is to multiply everything by a -1. So we are going to use this big shape. Oh, sorry. We're going to use this big shape, and we're going to multiply all of our new coordinates by a -1 and see what happens. But before we do that, I want you to predict what's going to happen to my orange shape when I multiply all the coordinates by a -1. Okay, let's see if you're correct. So, basically, I'm just going to take everything over here and multiply it by a -1. If you know anything about negative ones, you know that basically all they do is they change the signs of everything involved. Now these are all positives, which means that their new signs are going to be all negative. So we're going to have negative 4, negative 10, negative 10, negative 10, negative 6, negative 2, and finally negative 4, negative 2. So let's graph these points. Negative 4, negative 2 is going to be over here, or sorry, negative 4, negative 10 is going to be over here, negative 4 down to negative 10, which is right here. Okay, so that is negative 4, negative 10. Next one is negative 10, negative 10. So we're going to go over to negative 10, down to negative 10. And then we'll connect these dots. Okay. Then the next one is negative 6 and negative 2. So we're going to go to negative 6 down to negative 2, which is right about there. So negative 6, negative 2. And then the very last one we're going to do is negative 4, negative 2. Right there. So we'll put in our final connect the dots. This is a more interesting version of connect the dots than connecting the dots on a line. It's a little bit more fun. Sorry, I forgot to write this one. It's negative 4, negative 2. Okay, so let's see. If you said that the shape was going to flip, you would be correct. If you said the shape was going to move quadrants, you would also have been correct. Even if you said the shape was going to stay the same size, you would have been correct. Because if you look at this, the orange and my brown shape, same exact size. Nothing's gotten bigger, nothing's gotten smaller. So technically, what we just did was not a dilation, even though we did multiply the coordinates by something. What we just did was a reflection, which if you remember those from the Minecraft, so a reflection happened here, and then a reflection happened here. But it's just cool to show. Okay, so the next one we're going to do is we are going to multiply by a negative, or not a negative 4. We're going to multiply by a quarter, so 1/4. So before you do that, I want you to tell me in the Nearpod, what do you think is going to happen to my brown shape? Okay, let's see if you're correct. So when I multiply things by a quarter, or 1/4, what I'm basically going to do is I'm going to divide everything I see here by 4, right? Very similar to if we have a cup of flour, if we want a 1/4 cup of flour, so 1/4 cup, you would have to cut it in 4 pieces, and that's a quarter. So we're basically going to do the same thing here. We want 1/4 of each of these pieces. Some of them will go evenly, some of them will not go evenly. So we're going to take a look at negative 4, negative 10. We'll do this one in pink. Oh good, it still shows up. So a quarter of negative 4 is pretty easy, it's just a negative 1. A quarter of 10 is going to be a little trickier. So 10, if we cut that in half, is 5. If we cut that in half, it is 2.5. And obviously it's still negative. Okay, so negative 10, negative 10, we just found out that a quarter of negative 10 is negative 2.5. If you're ever unsure of what a quarter entails, like how to do it, cut it in half and then cut it in half again. Right, for instance, if I cut 4 in half, I would have 2. If I cut that in half again, I have 1. Okay, so now we have negative 6, negative 2. So same trick with the 6. Cut 6 in half and you get 3. Cut 3 in half and you get 1.5. So that's a quarter, negative 1.5. Now 2 is going to be fun because if we cut 2 in half, we're left with 1. If you cut 1 in half, we're left with a half. So negative 0.5. And then lastly, we have negative 4, negative 2. So again, negative 4 we've already found out is negative 1, and negative 2 is negative 0.5. I know this looks like a lot of decimals and a lot of negatives, but it's going to be okay. Bear with me. a lot of things when we're doing dilations, if you are dilating something by a scale factor that is a fraction or a decimal, you're going to end up with some decimals at play. And that's okay. Just means that we're only going to do about half of the box. So -1, -2.5, we're going to go -1. Then we're going to go down to -2 and halfway and put a dot in between. Okay, so that is -1, -2.5. Then this next one is going to be a -2.5 and -2.5. So we're going to go over to -2, halfway in between, and then we're going to go down to halfway in between again. So we have a dot right in the middle. It looks a little funky, but it's okay. I promise. Problem with markers, you can't go back. -1.5 and -0.5. So -1.5, and then we're only going to go up half a box. So again, we'll just have a weird little guy right there. And then lastly, -1, -0.5. So over -1, halfway down the box, put a dot. Now, something I want you to pay attention to. Hopefully, when you answered that in the Nearpod, you said that you thought it was going to get smaller, which is true. It shrunk by a scale factor of 4, okay, because we cut it into 4 pieces. I want you to pay really close attention to this because this is often mistaken. So in the Nearpod, I want you to answer me this. Have any of the shapes changed what shape they are? Have any of them changed? Hopefully you said no. All of these shapes are the exact same quadrilateral we started with. They've just either made bigger, made smaller, or gotten flipped over. But they are the same shape, right? I didn't start with a quadrilateral and end with a triangle. That would be kind of awkward. So it's really important when you're dilating things. If you, let's say, multiply everything by 2, and then you graph the dots and find out that you've all of a sudden made yourself a triangle or a square when you should have had this weird quadrilateral shape. That probably means that something you multiplied didn't work out. But that's okay. Go back, take a look at your points, make sure that you did that correctly. Don't just roll with it and go, oh, it's supposed to turn into a triangle. It isn't. It's supposed to stay the same. So I don't want to take up too much more of your time. Today's lesson, you have 3 dilations to complete. You have a dilation of a whole number, dilation of a negative number, and dilation of a fraction. So good luck. I'll be around if you need any help. Just so you know, tracer paper will not help a lot today because your shapes are going to be changing sizes. Anyway, have a great day, everybody, and I hope you enjoy dilations. Bye.